You can move it to the next screen. We've got the purpose of the transport layer, characteristics of the two protocol used at the transport. So you know this is where the segment's built, whether we're talking about TCP model or OSI model. It's where our port numbers get used and assigned, whether we're using TCP or UDP. So those are the two protocols that work at this layer. So we're going to explain the characteristics. We're going to explain the port numbers. We're going to go through how the session established or is established. And so we'll have a better understanding of the transport layer from end to end. So the role, again, sits right below the application. So the application, if we were talking about, you went the wrong way. Very good. So the transport layer is responsible for logical communications between applications running on different hosts. Is the link between the application layer and the lower layers. So what that means is our application at a server might be Apache web server. On the client, it's Chrome or Edge, Firefox, the browser. There's a presentation method. So they wrote the website in HTML5, it's going to be presented as HTML5. We have to have a browser that supports that. And then there's a session that maintains moving the data back and forth between the server and the client. All that's handled at the application, but it gets dropped down to this transport layer where we put the information into a segment and then pass it along to the lower layers. So this is kind of our what intertwines our application to our network on our devices. This next section here talks about the responsibilities of the transport layer. So again, you can see we're tracking individual conversations. The client there, the PC, has multiple things going on. There's header information on all of our segments. We have to have a way to identify, separate, and manage all these conversations because most people are using multiple applications all at the same time, right? You may have your Slack or some other communication method open in a window, Teams. You may have email open. You may have websites. You may be doing an online chat, streaming a movie. Multiple conversations. So how do we handle that? So TCP has a way for doing segmentation, break the thing apart, put it back together, and also something called multiplexing. So here the pink box on the left you can see says segmentation allows conversation multiplexing. Multiple applications can use the network at the same time. So this is the same method that we've used forever and ever to share an internet connection. It's not just you running your applications going out to whatever the application is. There's probably more than one of y'all using Netflix at a moment in time throughout the day. There's probably more than one of you guys using some chat IRC client. There's probably more than one of you going to google.com at the same time. So multiplexing is a way for us to share that network connection and allow these apps to all participate together. You can see it's got them all running. They're different colors because there's different applications going out in a line. So we queue them up, push them out as fast as possible. Segmentation facilitates the transport or the data transport by the lower network layers as well. Transport layer protocols we've just discussed. There's two, TCP and UDP. It ties them together right here. So you can see the FTP, HTTP, SMTP, all TCP applications. They use and rely on TCP. DNS relies on both. So it actually has a TCP side and a UDP side. So it's using both protocols. TFTP, Trivial File Transfer Protocol, which we use in the networking environment for moving operating systems to our devices, like switches, routers, firewalls. So very important for us to know, is a UDP application. IP doesn't specify how we deliver these things. It's all handled by these transport layer flow protocols. So how does this happen? So TCP and UDP do these things differently. So TCP provides reliable connections and something called flow of control. It tracks, it numbers and tracks. So there's something called a sequence number in a TCP segment that tracks it from end to end. We track the beginning of the conversation all the way to the finished end point of the conversation. And the application being used through acknowledgments and these sequence numbers. Anything that's not acknowledged gets retransmitted. If something arrives out of order, because we are maintaining and tracking this, we can put it back together. So sending the data at an efficient rate that's acceptable to the receiver. User Datagram Protocol, or UDP, has some basic functions as well for delivering data for applications. Its advantage is it's connectionless, which means we send and forget. We don't care the order of things. We're just going to send it over there and we're going to put it together as we receive it. We're looking for speed and lower overhead, so we're not consuming resources. So the applications that we use kind of dictate this. So you can see it's a connectionless protocol, known as best effort because we send and forget. We're not looking for acknowledgments. We're not going to be looking at sequence numbers. We're just going to put it together when we receive it. So when we're dealing with things like TFTP or voice, SIP, or video recording, we want to use something like UDP. Gives you guys some examples. Here's UDP is also used by request and reply applications where data is minimal and retransmission can be done quickly. So important that all data arrives and it can be processed in its proper sequence. So TCP uses protocol to manage this, or is one that we can manage. And it gives you some couple of different applications. So again, VoIP DNS, which uses both SMTP, HTTP, different protocols. So advantages for UDP, again, fast, low overhead, doesn't require acknowledgments. We're not concerned with lost data. We're not going to resend. We're going to put it together as it arrives. Email, web, those are connection required. So we're maintaining a session until we're done moving the data. We are error checking and acknowledging and resending when we lose stuff. And we're putting it all back together, the whole complete package, because we have all the sequence numbers. So you guys can see they're going to go through all the things that TCP does. So we got to send a SYN, and we got to get an acknowledgement to set up a session. If we can't do that, then the session can't occur. We need to make sure, for many reasons, it's possible for a segment to become corrupted or lost, so we're going to retransmit those situations. Ensures that the segment is sent by the source arrives at the destination. There's a same order delivery, so as it comes in, we're going to look at it. We're coming from different hours, it can arrive at different times. So we have those sequence numbers that allow us to put it back together properly. There's something called flow of control. This is important with TCP. So when I'm talking to a web server and a web server has nothing going on, it's going to let me send and receive as much as possible. based on our pipe. When web servers are overwhelmed and their resources are being consumed by all kinds of people, they can use the flow control and the windowing to tell people, hey, slow down, I can't give you as much stuff. So just be aware that that is built into TCP. They're going to show you guys the TCP segment in this format versus the UDP. So you got this purple box with all these different options. So port number can be from 0 to 65,536, I believe. The same as your number of networks on a Class B. So the way that they've got this set up, we got from 16 bits, right? See that? Source port 16, destination 16. So we know 2 to the 16 is 65,536 for doing subnetting. So based on the fact that we have 16 bits, I can do from 0 to 65,000 port numbers. They're well known, there's registered, and then there's other port numbers, and then we'll get into that in a minute. So below this source destination, you guys can see that there's a sequence number for tracking. It tells us, hey, this was segment 1, this is segment 2, segment 3, so on and so forth. There's an acknowledgement section. There are control bits that tell us which type of TCP segment we're sending. So just so you know, there's SYN, S-Y-N, there's ACK for acknowledgement, ACK. There's a FIN, F-I-N, that shows the end for finished. There's a RST for reset. There's a push, PSH, and I think there's a couple others. But those are the main ones that you'll see that are real important. There's a checksum section. We'll get into that. That's for error checking. And then it shows you the number of bits that each one of these things are. The flow control window size is set between the application, the server, and the client. So they maintain this through TCP. You'll see that over there to the right. All right, and then you got data, and the size is going to vary on the data. So if you click next, it's going to give you guys the definition of each one of those things that we just reviewed, the size of it, and what each one holds. Go to the next one. So again, TCP handles tasks associated with dividing the data into streams, providing reliability, controlling the data flow, and reordering the segments. They're going to give you, they just giving you some examples of applications. And all of these applications, I believe, are well known. They are. So well known means that the port number is 1023 or lower. IANA, again, has all those well-known numbers. You guys know you guys can search for those port numbers and find the document that identifies all the applications and the port numbers associated at IANA. So just so you guys know, if you guys were to look up SSH, you'll find that it uses port 22. It's well known. Does it mean that I have to run SSH on 22? No, it just means that's what's assigned to it by default. I can tell the server to run whatever port number I want to run. It's just not, it wouldn't be standardized any longer. HTTP, we know, is the unsecured version of the web. Most web servers now, if you hit them on port 80, will do an auto redirect, something we can build in through Apache or IIS. It says, hey, just move it to my secure site, HTTPS. So that's HTTPS and HTTP are two different protocols, two different applications. One has security, one does not. That's why the S version of it runs on 443, a different port number. FTP is a weird one. It's actually got two port numbers. So if you guys just open up port 21, you haven't opened up FTP. You're only allowing the data portion. There's actually a 20 as well. So port 20 and 21 is FTP. It's two. There's not a whole lot of two port applications, but that's one of them. And then SMTP, which we're using different methods to send now, just so you guys know. SMTP is the protocol we use within a mail client to send email. That's the sending portion only. That doesn't have anything to do with receiving. So you guys are probably used to running an app on a phone, like Outlook or Gmail. And that's an app, and it doesn't make you do a lot of configuration. It says what's your email address, what's your password, you put it in, and boom, all of a sudden all your mail starts flowing, right? Same if you do it through a web browser and you're looking at it in the actual web browser application. But if you're if you're setting up an actual client, then you need to know how that works to configure it. So for example, Outlook on Windows, the actual application that you install, requires you guys to put all that information in there. But anyway, that's port 25. Next slide. Now we get into UDP. So you can see that data is reconstructed in the order it's received. We don't have any sequence numbers here. If segments are lost, we just deal with it. That's how you kind of know when you're having voice issues. So when networks are good, everything's running correctly like it's supposed to. We're seeing packets flow. We're not having errors. Everything is good. With UDP, if your network's poorly done and you're having problems or your connection's not good, real relevant. I mean, it's right there in your face that you're having problems because the call quality goes way down. Like you can't complete a call, can't receive a call, or the audio is just real bad. The good signs of something's going on with the network. There is no session establishment with UDP. Again, it's a set and forget it. We're not sending and informed about resource availability either. So it's either up, online, working, or it's not. UDP header looks a little different than TCP. It does have an error checking section, but it does not, again, keep track of the sequence. It does not keep track of the order of things that they're sent. It's going to send them and then forget it, and then hopefully they get over there and get put back together correctly. Still have the source destination port. That's required at the segment level, whether we're running UDP or TCP. So over here, it's going to define those fields, what goes in each one. This next slide shows us some of the applications used by UDP. So again, it's a send and forget it thing. So for example, DHCP, we don't have an IP address to begin with. We don't know where the server is. We're trying to obtain an address. The quickest way to get it out there and get the message back is through UDP. So DHCP uses, I believe, 67 and 68. It also does have a TCP mechanism as well. So that's another one of your dual protocol or dual transport protocol things, just like DNS. TFTP that we're going to use in a lab to move IOSs and backup images on the equipment in the lab is an application we can run. You guys can search for OpenTFTP server. It's something you guys can download and install and play with. SNMP is another one in the semester 3 that we play with. It's a management protocol. It's how we can get information from servers, switches, other equipment on the network, printers, good source of information. So if somebody jams one up, I know about it before they can call in and say, hey, my printer's not working. Yeah, we know because you've got a paper jam over there. You have to unjam it, open up the tray, look for what's got it clogged, even though it has a message, right? But SNMP will send us those. Or they'll call because it's out of paper. Hey, it says it's out of paper. You check the tray. Oh, you're right. So the SNMP protocol is one of those things that lets you get alerts about things before they happen if you're monitoring. Again, VoIP, which is SIP and video conferencing all use UDP. So this next section goes into port numbers. Again, there's a source and a destination. They don't always have to be the same because of IPv4. We're talking about IPv4 version of TCP or UDP. The port number on the source may vary because it's tracked by the application in the session and the router. So we do the next section. The source, destination, port, and the IP address, when we pile it all together, it's what we call a socket. So you can see here, the source, destination ports are placed within a segment. The segments are then encapsulated with an IP packet. The combination of the source IP, the source port, the destination IP, and the destination port is what we call a socket. The sockets enable multiple processes running a client to distinguish themselves from each other and multiple connections to a server to occur. So you can see that the source port on the client, remember it's going through NAT as well, is not going to match the well-known port on the other side. So the server port 21, which we know 20 and 21 are the FTP, remain the same at the destination. They have to. On the client, it's some randomized number. All right, so for it to be well known, it's got to be from 1023 down to 0. So again, you guys can see because we're going from 0 to 65,535. That's 65,536 ports. Register ports are port numbers that are signed by an IANA to a requesting entity, the specific processes or applications. They're primarily individual applications that a user has chosen to install rather than common, and would receive a well-known port. So, for example, Cisco has registered 1812 for Radius, Microsoft 3389 for remote desktop, SIP 3050 for voice applications, that's UDP. RTP is the audio for SIP. I think it's also audio for some of your gaming environments and things that you guys use. Those ports are going to vary for RTP. I can't give you a number with that because it's going to be dependent on what you guys are doing. So you guys have like Xbox, right? Does everybody have an Xbox or a PlayStation something? And they all have these audio headsets now. Y'all use those? So you're doing some form of VoIP right there. If y'all Wireshark the Xbox, which to do that you'd have to have a hub in between, or you'd have to have some special port capture utilities. But that's a VoIP application. It's probably running SIP. It's probably running some version of RTP. The Xbox or whatever the game system is defines the RTP side of things. If you look up RTP for like Panasonic voice, their phone system may be completely done different than Xbox. If you looked up Avaya, they're a well-known voice product thing. Their ports for RTP and the audio may be well different than everybody else. Does that make sense? So the SIP, the 3050, is pretty standard. There's a secure version of it at 3060. But the UDP 3050 version is just setting up the establishing the call. So that's you talking to your buddy on the other end of the game, right? It sets that up. The actual audio that's going back and forth that you're hearing on the speaker and that goes through the mic is handled through RTP, a different protocol. Just know there's two. If you're in control of the network, you can see more than if you're not. So here's your local ports. Again, 2021. The data's flowing on 20. The actual setup of the session, the user authentications on 21. 22, secure shell. We actually use this and bind secure shell to FTP. So just so you guys know, to make secure FTP, there's two versions. There's SFTP and then there's FTPS. Those are both different, right? But they're both secure. So if you see the S in front of FTP, they're using SSH to secure and encrypt the data. Right? If you see the S on the back side of FTP, FTPS, then they're using HTTPS 443 to secure FTP. So two different ways that you can secure FTP. FileZilla is a client application that you guys can download and use. If you have an Orca account, you can actually use that to make a connection to Orca, and you can dump files back and forth. You guys can do a Wireshark while you're doing it, so you can see how TCP handles FTP. Telnet is a unsecured version of SSH, port 23. The Simple Mail, again, we're not using SMTP as much anymore because it's unsecure. We're using a secure version of SMTP. We're either running it with TLS or SSL, hopefully TLS. The port numbers are dictated by your provider. So I think, for example, if you're using Gmail, it uses ports on the send 465 or 587, depending on how you're doing it. The receive port is different. The receiving can be done with POP or IMAP. Again, if you're using POP, old POP was 110. There's a secure version of POP, just like there is with SMTP, and so those port numbers are going to be different. I think it's like 993 for one and 995 for the other. So because there's two applications, there's POP and there's IMAP, which they have here. Again, 143 is the normal, well-known, but there's secure versions of both of these now. Those are the receiving part of the email with your Outlook clients and things. There's your DHCP. I told you all there was two ports, 67, 68. I think I nailed those. 69 is your TFTP. UDP, TCP, 53 is DNS. NetStat can be used to see the connections, the source destination, and the port number. It will do labels when it recognizes it. So HTTP is a well-known name for 80. So instead of throwing an 80, it's just put HTTP. You should know that that's 80. You can also see the state of the communications there. So the next section goes into the process. So you guys can see the source destination sending to the server. I'm not going to spend a lot of time on this. I'll let you all walk through the connection establishment. Go to the next slide. This right here is important. I'm going to walk you through this. So this is what you're looking for in Wireshark. You want to see the start process, the initial send. So if you'll look here, the first thing that the client, when you open up the browser and you type in the address and you press enter, does is it sends a SYN, S-Y-N-N, S-Y-N. So TCP send. It has to be a TCP application for this because it's connection oriented. When it's received by the web server on the other end, it has to send back a SYN ACK. So it's going to say, hey, look, I'm acknowledging that you're requesting my website and that I have one and I want to establish communications. So the client's going to receive that SYN ACK and then it's going to respond with an acknowledgement. So you can see it's responding with an acknowledgement. There's sequence numbers the whole time and acknowledgement numbers the whole time. When it sends back the acknowledgement, these guys are going to start the session. So you're going to get an established session at NetStat. If you're fast enough, you can refresh the NetStat and catch it flipping states, but it's easier to do with Wireshark. All right, next slide. So here, this shows you we're done communicating. We're tired of talking to one another. There's a fin, F-I-N, that's used to say, hey, we're done. So you can see the fin gets sent. Acknowledgement's required. Hey, I received it. I acknowledge. Then the fin comes in, and then we stop the communications. That's the session termination process. So there's a start. We're sending, and then when we're done, we send a finish. So that's when it knows, hey, we don't have to deal with the sequence numbers and anything anymore. So here we got the functions of the three-way handshake. So this establishes the destination device is present, verifies that it has active service, is accepting requests, informs the destination device that I need to establish communication on a port. And then after communication is completed, we're going to close the session and end it, terminating. When you have a server that is getting sent bogus sessions over and over and you don't have something to stop it, that's when you get DDoS. So y'all are wondering. So there's only 65,000 potential ports, and if I'm a server in an application, I'm standing up ports left and right and maintaining communications. If it's not an in and out conversation, I can run out of ports. Okay? If I run out of ports, the application is going to end or die. So that's, if you're wondering how they DDoS, or they used to DDoS servers, we now get in between sessions and we're looking for folks to do stuff like that. We kill their connections before they can shut down the application. It's how Google, I mean, there's no telling how many people are watching their stuff and how many different servers. The other way you minimize it is by having a distributed network out there where we have more than one thing responding to requests. You guys saw that the numbers for Google's change, right? When we're looking at it from a standpoint of NSLOOKUP or whatever, the number for Google may vary. This is this next slide goes into the analysis of it. So that control bit section, this 6 bits, these are the different values that you guys can have. So you can see there's the acknowledgement flag. We have the reset to reset a connection when we have an error. We have the SYM for synchronizing sequence numbers used to establish the connection, and we have the FIN to terminate end our session. There are some other ones like the push and the urgent pointer field, but the most important for you guys right now are the ACK, the SYM, and the FIN, and understanding that three-way handshake process. So we're going to get into the reliability, guaranteed order delivery. So you can see that they may not arrive in order, but we can put them back in order if we're using TCP because of that sequence section. We maintain flow of packets so we don't get overloaded. So there's something called windowing, and we can make sure that we don't get overloaded. There are times when TCP segments do not arrive at the destination in order, and we can reassemble them. The segments must be reassembled so that they match the original, so that we have 1, 2, 3, 4, 5, 6, and not 1, 2, 6, 5, 4, 3, like it was seeing here. Again, these sequence numbers are assigned and maintained as part of the TCP process. The other thing that TCP brings is the ability to check and find an error. So if we don't get an acknowledgement that a segment got to the other end, then we say, hey, I got a problem, I didn't get an acknowledgement, resend it so that we can get it. There's some reliability of that. So again, it's going through the whole send, resend. On to the next, there we go. So the flow control window size and acknowledgements. This is the amount of data that the destination can receive and handle reliably. It uses that window field to change the MTU. We just discussed this the other day, right? So the jumbo frame is something new that you guys are allowed to use in a network environment. It's not the norm for Ethernet. Ethernet is up to 1,500 bytes. Our software can adjust the size up and down based on what it can handle. All right, so this is a maximum segment size. We handle that through windowing. This flow control helps maintain the reliability of our sessions or applications as we're sending and receiving and using them. So again, you guys can see that it goes through the process here, shows you how we have an avoidance mechanism. So when congestion occurs, network results in packets being discarded. The congestion, TCP employs several congestion handling mechanisms such as timers and algorithms. UDP is a little different. It's real basic. So you can see that there's some devices that use UDP. When we establish a phone call, we're not setting up a session. It's not being maintained. There's the error checking's there, but we're not going to resend packets. Low overhead is send and forget. We're not checking for things. You can see that we sent 6 datagrams and they received 12654, and that's the order they put them back in on the other end. They're not reordered. So the application puts the stuff back together and lets us hear what is being sent through the phone. We're not tracking it. There's no way to reorder it. It just simply reassembles the data in the order that it's received and forwards it to the application and let the application deal with it. Does that make sense? We don't want to be missing pieces, but it happens. The applications have been written to deal with that issue. So UDP-based server applications are also assigned well-known or registered ports. UDP receives a datagram destined for one of these ports and forwards application data to the appropriate application based on its port number. So you can see here they're going to do a DNS query 53 client process. And we're done.